A very good evening, dear students. So here we are with the second session, a very basic yet very important session on magnetism. Now, this session is basically known as Earth and magnetism, or you can call it Earth as a magnet. Okay, yeah, our Earth basically behaves like a giant magnet. All right, let us dive a bit deeper into this concept, and let us try to understand what do we mean by Earth as a magnet. And in this session, we would use a very basic compass to learn few facts. Okay, let me share the screen with you. I hope it is visible to you. Yes. So this topic will be integrated study between geography and physics, of course, as we are studying about Earth. So now the very basic thing, okay, uh, if we consider this shape to be Earth. Now you must say that, sir, this is not a circular shape. Of course, our Earth is also not a circle, right? It's a geoid shape. It's an undefined geoid shape. All right. Now, what we can do is geometrically or hypothetically divide it into four quadrants as we do to all the surfaces, right? In geography, you must have learned by now that the axis on which the Earth spins is basically tilted. It is tilted. If we draw like this, roughly, it will represent the axis on which Earth is rotating. Okay, Earth is spinning, maybe in this direction. All right. Now, what is this point, students? This point over here is basically geographic the geographic north pole, remember. And similarly, this point over here, definitely it will be geographic south pole. This is clear. Typically, when we observe or when we assume the earth to be a giant magnet. Now, before you ask questions on how it is happening and all, we'll dive deeper into it. So listen to this very carefully. When we assume the earth to be a giant magnet, typically the poles does not coincide with the geographic north and south pole. Typically the poles lies somewhere over here. That means if I draw the magnetic axis, it will lie somewhere over here. Am I clear? Okay. What is the difference? Now, you can clearly see that there is a angular deviation, right? If this is the geographic axis on which Earth is spinning continuous, this is the magnetic axis. So there is a clear-cut angular deviation. This angle is roughly 10 degree to 12 degree. It varies. Okay, why it varies? That also I'll tell you. Okay, so this is how it basically looks like. Okay, now the fact is that why why Earth is behaving like a magnet? What is the reason Earth is behaving like a magnet? Isn't Earth a planet? Then how can it be a magnet, right? Now Earth is behaving as a magnet. You have to understand that concept, you have to understand the layers of Earth. Okay, we know that among the layers of Earth, the first layer is the Earth crust. Below that, roughly I'm dividing it into the layers. Below that we have the mantle. Below that we have the outer core, which will be very important for us. And in between, like at the center, is the inner core. Okay, so if I point it out with a different color, let me choose. Yeah, so if this is the inner core of Earth, then I'll mark it with the different color. Here it will be the outer core. Okay, this whatever pink color represents the outer core. Now try to understand why there is a distinction. Why there is a distinction, that is very important for you to understand. This inner core, typically, due to its high pressure of the Earth's crust and mantle, due to its high pressure, it is solidified. So the inner core is solid structure. That's what the prediction and assumption of the scientists are. Whereas the outer core is not solid. It is basically a liquid structure. Okay, it is basically a liquid structure. Now, what is the very basic property of a liquid? A liquid must flow. A liquid must flow. So that means the particle which is over here, after a few years, it will not be here. It can be over here or over here or over here. That means this whole structure is basically flowing. Clear? And the most important thing, what is this structure made up of? What is this whole structure is made up of? This fluid, what is it made up of? Mainly, primarily, it is made up of iron. I hope by now you know Fe is the symbol of ferrous or iron. It also have nickel in some quantities, but mainly it is of iron. Now try to understand iron. Okay, the most familiar element, I should say, from periodic table. Iron have a typical magnetic property. Okay, iron, and at high pressure and high temperature, because the core, you see, all this pressure are there, all this high immense pressure is there. So due to that, and due to the flow of this whole outer core liquid region, fluid region, there is a generation of a characteristic which which we call it as which we call it as magnetism. So if you are imagining that this is Earth and there is a huge bar magnet hidden somewhere inside the soil, that is wrong. Okay. So the structure basically is, this is Earth, and due to the flow of this liquid iron, for now you can say liquid iron or liquid metallic structure, the Earth, the planet, emits a field. Now in the previous session, you know what is field, right? It emits a field which basically is called the magnetic field. Since it is emitting a magnetic field, that is why we are calling the Earth to be a magnet. Okay. Now let us jump to the observations that we are going to make. Okay. What observations? What are we studying over here? Try to understand. Now, the most important property that we are going to study is called directional property. What do directional property means? See, if you have attended the previous session, you know, unlike poles, they attract each other. Okay. And like poles, they repel each other. And if you remember, I told repulsion is a much important property than attraction. And by now you know why, to determine the magnetic properties. Okay. Now try to understand. When I say directional property, what do I mean when I say directional property? What I mean is, if this is Earth, okay, and as I said, this is the geographic, I am writing geographic North Pole. This is the geographic South Pole, okay, and somewhere over here is the magnetic what pole? We'll come to that later. Okay, magnetic poles are somewhere over here. Now we'll take the example of a compass also, but for now let us do something that is very familiar, okay, that we all have done. Let us take a bar magnet, okay, North Pole, South Pole. Let us take a fixed support and let us hang this bar magnet from the middle. Hang the bar magnet from the middle. What it does, it basically suspends freely like this. Okay. Sometimes it will rotate like this, and then it will be stable at a particular direction. That means these poles, they are pointing to the unlike poles. That means the south pole is attracting the north pole of this magnet, vice versa. The north pole somewhere is attracting the south pole of this magnet. Okay. Now, when we do it over here in our general conditions, what we see is the markings that we have made into the bar magnet, that the poles, how they are, when we suspend them freely, okay, when we suspend them freely, the north pole that we have marked in a bar magnet is pointing somewhere over here, and the south pole that we have marked in the bar magnet is pointing somewhere over here. Okay. So what conclusion we can draw? The conclusion that we can draw, that if this is the magnetic axis, okay, if this is the magnetic axis, this point, where north pole of the bar magnet is pointing. So if north pole is getting attracted to a particular point, listen to it very carefully. If north pole of a bar magnet is getting attracted to a particular point, that means that point must be south pole, because unlike poles will attract each other. If south pole of the bar magnet is getting attracted to a certain point, that means this must be north pole. So the conclusion that we can draw, by now you have understood what I'm about to say, the conclusion that we have drawn, that the geographic north pole and the magnetic south pole lies along with each other. Okay, if we ignore this angular deviation, if we ignore this part, we can say that the geographic north pole lies along with the magnetic south, whereas the geographic south pole lies along with the magnetic north pole. Okay, what is the observation, what is the use of this whole thing that we are studying, right? That you need to draw a conclusion of. Okay, so when, let me tell you the use of it. Okay, now here is a compass that I have. Okay, there is a compass. Now if you have seen the compass, you must have seen that the red marking, basically there is a needle, the magnetic needle that we say, and the red marker, we denote that as a north pole of this compass. Okay, north pole of this compass. Now try to understand if I am having a compass, okay, on which there I have a needle like this, and the red marking is basically the north pole. This needle is a magnetic needle. Okay, this needle is a magnetic needle, this needle itself is a magnet. The red marking is the north pole. So if this red marking is pointing at certain direction, that must be, there must be a south pole existing over there. Okay, and vice versa, there must be a north pole existing somewhere over here. That is why the south pole is pointing over here, unlike poles is attracting. Okay, so by default, what we see, what we observe is that this pointing is true for our geographic poles. That means here, if I draw the earth like this is how it is pointed. Okay, the Arctic region over here, the Antarctic region over here. We know the Antarctica lies near the South Pole. That is why it helps in navigation purposes. Okay, any compass in the world you take, this is the very basic phenomena. Okay, that is how it helps. So let me conclude the video by telling you what conclusion and what is the daily life example that we can draw from this topic in itself. Okay, so number one, what we have learned is the directional property. The directional property, that means if a magnet, any kind of magnet, is hanged freely, it will hang for some time and then it will settle down in a north-south directional position. Okay. Number two, one of the most important conclusions that we have drawn, the geographic north pole lies along with the magnetic South Pole, and the opposite also true. Geographic South Pole lies along with the magnetic North Pole. Okay, that is why in my compass, when it shows the north and I also go in that direction, I will go towards the geographic North Pole because the magnetic South Pole is there. So the north is basically pointing towards the magnetic South Pole. That is the fun in magnetism. Okay, so these are the things that we have learned. Now, a very interesting task that I'm giving you while concluding the video. Have you heard the name of a phenomena called aurora? In Norway or anywhere, if you have been to those countries, you must have seen the night sky filled with green lights, right? Green lights like this. Okay, so those are called aurora borealis. Okay, the task for you is to find out why this happens only in those areas. Why not in India we can see aurora every day? Okay, the task for you is to find out why and how this happens. With this, I'm concluding this video. I hope it is clear how Earth behaves as a magnet and what is the use of it. So with the aurora part, we will start our next session. Thank you very much.